Extraction of metals, next part of the discussion. Extraction of metals which are moderately reactive. If you take moderately reactive, example, you can take lead, and you can take iron, and you can take zinc. So particularly here, if you take iron, zinc, and even copper also, if you take here lead and copper, both of these, they undergo self reduction. Both of them, they undergo self reduction. So what I'm doing here is, in the case of lead, if you take PBS, galena, it is subjected to roasting. If it is subjected to roasting, it forms lead monoxide plus sulfur dioxide gas. This is solid, and this is gas, and this is also solid. So take this lead monoxide gas, lead monoxide solid, and again treat it with PBS solid. It undergoes auto or self reduction to give Pb solid plus sulfur dioxide gas. So to balance the equation, there are two oxygens there, so take 2 over here and take 2 over here. So here the lead which is obtained is the pure form of lead. Similarly, if you go for copper, if you take cuprous sulfide, it's a pyrite mineral ore, Cu2s plus O2 gas gives rise to roasting. So you get Cu2O plus sulfur dioxide gas. Balance the equation. I think the reaction is already balanced. This is cuprous oxide. Take this cuprous oxide solid, and again you treat it with the cuprous sulfide, subjected to auto or self reduction, and finally we get copper and sulfur dioxide gas solid. This copper which is obtained is called blister. It's called blister copper, which is the purest form of copper. I think if you are going to balance the equation, there are two oxygens, so take 2 over here, and here 2 plus 2, total 6 coppers are there, so take 6 here. The reaction is balanced. So the obtained copper is called blister copper. In this way we can just go for one more reaction, that is C. Go for iron pyrites, or simply oxide of iron. Oxide of iron, when treated with the carbon acting as a reducing agent, we can find that we get iron solid plus carbon dioxide gas. This is molten iron. Balance the equation, take 2 over here. There are 3 oxygens, so take 3 here, take 2 here, so take 4 here. Number of irons, number of oxygens are balanced, so number of carbons we need to balance. This is carbon solid, this is also carbon solid. The reaction is balanced. Likewise, if you take titanium chloride, if you treat it with the more active metals, titanium chloride, if you treat it with more active metals like aluminium solid, you can easily get titanium solid plus aluminium chloride solid at a high temperature, at around 1200 degrees centigrade. You can continue the reaction. You can balance the equation. Here we have 4, here we have 3, so here you can take 4, here you can take 4, and here you can take 3, take 3 here and take 4 here. The reaction is going to get balanced. So the last part of the discussion, that is to go for displacement. Reactions, it is valid for less reactive metals like gold and silver. So you take argentite, Ag2S silver glance. This is silver pyrite or simply silver glance. The silver glance is treated with the sodium cyanide. aqueous, this is solid aqueous, this is acting as a leaching agent. It forms a complex immediately, it forms a complex, it forms sodium argentocyanide complex, it forms sodium sulfide as a byproduct. To balance the equation, there are two silvers, so take 2 over here, 2 2s are 2 sodiums and 2 sodiums, 4 sodiums, so take 4 over here, 2 into 2, 4 cyanides, reaction is balanced, and this we call it as sodium argentocyanide. Sodium argentocyanide complex. Take this sodium argentocyanide complex, NaAgCN taken twice, and treat it with zinc, which is acting as a reducing agent. Immediately it forms Na2ZnCN taken 4 times plus Ag silver. So here you take 2 over here, and there are 4 cyanides and 1 zinc. So here we have 2 sodiums, 4 cyanides, 2 silvers. Yes, the reaction is balanced. So this is sodium tetracyanozincate, and this is the metallic silver, molten silver is obtained. This is one of the best examples of displacement reaction for the extraction of, that is, the less reactive metals, that is copper and silver. So here I have given you the example of silver, how to extract the silver. The same method you have to apply even for the extraction of gold also. So gold and silver, both of them follow the same method, that is displacement reaction method. Here the zinc is trying to displace the silver in the form of molten silver, which is in the pure form. So the next part of the process is, that is Goldsmith's aluminothermic process. In this Goldsmith's aluminothermic process, if you take Fe2O3 solid, and if you treat it with aluminium solid, which is a reducing agent, similarly chromic oxide plus aluminium solid acting as reducing agent. Here in both the cases, aluminium reduces the oxide of iron to molten iron, and you get aluminium oxide solid plus heat, large amount of heat is generated. Here also, if you take chromic oxide, aluminium as a reducing agent reduces the oxide of chromium to chromium solid plus aluminium oxide solid plus heat. Balance the equation. There are 2 chromiums, so take 2 over here. There are 2 aluminiums, so take 2 over here. There are 2 irons, so take 2 over here. There are 2 aluminiums, so take 2 over here. So therefore it's an exothermic reaction. This is also an exothermic reaction, and this iron which is obtained is red hot molten metal, which is used in bridging of tracks, railway tracks. It is used in the welding purposes or the bridging of railway tracks. That's why we call it as the exothermic